Welcome to another edition of Flutter Embedded. Today we're going to cover using I2C and the BME280. We're going to add a temperature, humidity, and atmospheric pressure sensor to our Raspberry Pi using Flutter and I2C. About 9 basic steps. Let's go over the equipment list, what you're going to need for your development system. And this is what I use. The main thing is 8 gig of RAM. I use SSD. This is for development. It'll run on the Pis with less memory, but you're going to need a breadboard, some wire, and you need a breakout board. I will put a link in the description of what I use. So let's go ahead and get ready to wire up this circuit. I suggest you use the BME280 that I put in the description because there's a lot of different ones, different pinouts. Basically, you need 3.3 volts ground, the clock, and the data. The default on the Raspberry Pi is shown here. We're going to GPIO 3 to the clock and GPIO 2 for the data line. That's all you need to get this thing hooked up. If you use any other modules, you can send a comment to me. I'll see if I can help you. But this is the one that I recommend you use. Now, the first thing you got to do is enable your serial I2C in the Raspberry Pi. So you can do it 2 ways. You can do sudo rasp-config from a terminal and go into interface options. And scroll down to I2C and say yes. And I'm recording the screen, so it would want you to reboot. You have to reboot for that to work. Now, if you have the desktop, you can also go into the desktop, into the configurations, and do the same thing. So do one or the other. You don't need both. So I'm just showing you that if you're going to use SPI, or you're going to use the UART, or you're going to use one wire, this is where you could go in. You could also do it through the terminal. You don't need to do both. Just pick one or the other. After you do all this, it's going to update, and then it's going to ask you to reboot. It's going to add all this into your config.txt. So I'm recording, so I'm not going to reboot right now. Now, there's a cool thing in the Raspberry Pi, in the Linux, that you can check before you do any coding to see if you're actually connected. So this by default is loaded, but just in case it's not, sudo apt-get install I2C-tools. And it's already, in mine, it was already in there, but just in case, that's how you load this. It's a tool set for you to check your I2C stuff on your system. So right now, we're going to see if this device is wired up. And I didn't spell it right. Let's see if I can fix that. Detect. -Y, and then the 1 is the channel. And there you have it. The default address for our chip is 76, so it's connected. Now let's go ahead and set up the Flutter project. I will have the source code link for the final project in the description. So, because I'm going to move pretty quick through this, or we'd be here an hour. I'm going to go through it pretty quick, but you can download it and just kind of paste, or if I'm moving too fast, you can stop the video and also look at the source code. So we're going to create a project. You go to view the command palette, pick where you want to put it. I'm going to call it Flutter Embedded for my folder. And select that folder. Now give it a name. I try to name it something so if I have hundreds of projects, I can figure out what was this? What was I doing? Now the system's a little sluggish because I'm recording at the same time I'm doing this, but I've got it overclocked just a smidge, and I found you cannot overclock too much. Okay, yes, I'm the one who created it, so I trust myself. Oh, we've got it set up. Now let's go ahead and create folders, files, and install package. Now, on your machine, it's going to take a little longer because I'm cutting out and coming back in, or this would be a very long video. Okay, we're going to create a couple folders here. I create a folder for my custom classes, and I create a folder for my screens. Okay, so in my code, that's what I'm calling it. Typically, whatever you name the file, that's going to be the class name. That's convention. I've done this so many times that I got out of sync, but that is convention. And in VS Code, you have to put .dart. It doesn't automatically create a Dart file. And I have made that mistake several times and couldn't figure out what was wrong. But you have to put .dart, and what I did right there. Okay, so I'm going to create home. You always use this snake case. That's Dart convention. And we're just naming files and folders right now. We're going to come back and we're going to get rid of all this main and just cut it out. And we're going to paste in from my code. You can change the title if you want. There's a couple of errors there because I cut and paste. It doesn't know where that home screen is because we haven't made it yet. Now we're going to pub spec YAML. That's a whole mouthful and a whole class in itself, but this is where we're going to add the package. And you do flutter pub add, and then the package name, and it'll take care of the rest for you. Now this takes a while on the Raspberry Pi, so I'll come back when it's done. There, we're done. And let's scroll down and you can see where it put this package. The magic's all happening in the Dart periphery package. Now we're going to start copying and pasting code from my code. So let's see. Let's go. I'm just showing you a few things there where you can do run, debug, and profile, but I want to get over to that's the material.dart you need for your Flutter. Let's go to the home screen. And if you type in STFL, it's going to give you that. You click on it. That gives you kind of the boilerplate code. And you can see you type in one place, it types everywhere else. And go to main. I'm going to fix this error right here. If you right click on it and go to quick fix, this is one way to do this. And then import that. It'll automatically import it for you. So you can see right there. Now this custom class is empty right now. I just pasted it in from my code. A lot going on in there. But this is where all the magic's happening. That's the Dart periphery package. And then I use foundation.dart because I use debug print. I never use print. Debug print is a convention that's good for production code. So if I want to print to console, I use debug print. Now, the class should have been named the same as the file name, so shame on me, but that's good enough for this tutorial. So I2C BME280 get data. We've got a variable that's going to hold this right here. I'm going to hover over this. And this opens the I2C. This is from Dart periphery. And then we got 3 strings. And we've got this dynamic that we're going to put some stuff in. The first method I create is to initialize the chip. And then I use debug print so I can see that that all worked as expected. Then 3 more methods: get the temperature, get the humidity, get the pressure, the atmospheric pressure. And then dispose. If in a bigger program, if you're going to move away from the home screen, you need to dispose. In this tutorial, we're not going to use it. Now let's go back to the home screen. I'm going to cut and paste. And we're just going to start the first test. We're just going to see if we can get the temperature. Now this sensor is very, very accurate. Good for temperature, humidity, and atmospheric pressure. So let's start with something easy. You see right there, it's barking at me, where is this file? You just hover over that, quick fix, and it'll import it. So I've got 1 string, temperature. And then I've created a method down here to return an elevated button widget on pressed, and then set state. You got to use set state or it won't change. These are warnings. It likes you to use the constant, but right now we're just going to ignore them. And then save. I'm showing, I would normally do Control S, but I'm showing you got to save. Now, the fun part, we can finally test this thing. Now, in problems, there's only 3 warnings. So you got to pick the available device. And right now, we only have the Linux desktop. So make sure you pick that. It's going to ask you, it won't go into debug. Now, you can press F5, or you can hit that little triangle right there. F5 will start the debug. This is going to take a while. So I'm not going to make you watch paint dry. We're going to zip on over when it's done. As long as you see stuff moving around, it hasn't crashed. So eventually this screen, if you have more than 1 screen, it may show up behind something. So if you can't see this, dig around. Okay, so when you click on it, if you heated that IC up, that would change, like use a blow dryer or something. So it works. That little square up there, that's how you stop it. Okay, now we're going to add humidity and atmospheric pressure. This is a very basic tutorial, so we're just going to be able to grab the data. If for advanced programming, picking the device. You could use a polling method. You could get off the main thread. You could use block. You could use provider. And you could be updating every 400 or 500 milliseconds and using your temperature and humidity, atmospheric pressure as part of a bigger control system. But right now, this is just showing you proof of concept and how to get the data. So we're going to take this method, returning the elevated button widget, and just copy it and change a few names. Because we've already got an instance of the class, we're going to use dot notation for grabbing our methods. So we'll change this to humidity. Name it whatever you want that makes sense to you. And then if you erase that, you'll see that pop up because we already have that method created. And then change this. Now, the way Flutter's working, we're using a stateful widget, so we have to use the set state. Every time you hit that button, it changes the widget tree to update. I forgot to add these strings for humidity and pressure. Just above that is where I create an instance of the class, the final, up there. That allows us to use dot notation inside of our methods in this home screen. Okay, I'm just creating these empty strings. And we'll go back down to the methods. Now I can use humidity value. And for some reason today, I cannot spell. You're going to see here in a minute that I misspell humidity. And I caught it later, but so if you see a few misspellings, it's because my mind is thinking, this is going to be so cool when this works. So we got that. Now let's copy and paste, and we'll do atmospheric pressure. This chip is really cool. It can actually act as an altimeter. It has the capability of you giving it the actual barometric pressure where you are, and it'll calculate the altitude based on the atmospheric pressure, just like an aircraft. We're not using that right here. We're just grabbing the atmospheric pressure that it's reading sitting here on the bench. But it's a really, really cool chip. A lot of use cases. Okay, so we've got pressure value. We're going to change this dot notation, and I misspelled atmospheric. I like to use Android Studio because when that happens, it will highlight that and tell me that I misspelled it. So I'm so used to that I don't know how to turn that on in VS Code. If you know how, please put it in the comments. But Android Studio would have said, no, you misspelled atmospheric. Even a camel case, it'll tell you one of those words is misspelled. So I wish they had that in VS Code, or tell me how to turn it on. Other than that, just a couple of misspellings in humidity and atmospheric, but it's going to work. I just want to see this thing work. I'm kind of excited to see showing you how you can use this chip. Oh, I am going to go ahead and fix this. I lied. I knew something wasn't right there. Okay. Now we'll copy that method right there, and we'll go up into the widget tree. And I'm using a sized box to space between these buttons. I'm not styling these buttons, but there's some phenomenal stuff you can do with these buttons. You can do, I've done elevating them. I've done different shapes. I've split them, put rows and columns, icons, just incredible amount you can do with these. So we're just putting in, we've got temperature, then humidity, and then pressure, and we're spacing them with a size box. I've got them in this scaffold, I've got them using the main axis alignment and cross axis alignment to get them in the center. Okay, we're going to pick the device, hit debug. And what I have been waiting to show you is how you can get temperature, humidity, and pressure from this using I2C Flutter on the Raspberry Pi. Phenomenal. This is the building blocks for most of the control systems you may be needing for your systems. Now, right now, you click on it. If you were heating this up or you were changing humidity, it would be showing. So I'm excited to show this to you. There are going to be more videos coming. We're going to use SPI. We're going to use UART. So subscribe and stay tuned for more videos.